In this lesson, we will talk about roses and lemniscates. Roses are curves that take the form of either one of the following, where a is a non-zero real number and n is a non-zero natural number. That means a number that is a whole number that is positive. For example, 1, 2, 3, 4, 5, etc. We have r equals a sine of n theta, or r equals a cosine of n theta. A couple of these curves should have been demonstrated in some of the examples in this section. The value of a, the coefficient on the trig function sine or cosine, will indicate the radius of the rows. By that I mean it will indicate the radius or the circle within which the rows sits. For example, if I have a rows with a value of a of 2, that means I might see a rows that look something like this. And this rows would fit within a circle that has a radius of 2. So each petal has a length of 2. The value of n, on the other hand, will help determine the number of petals in the rows, which is very, very nice. If the value of n is odd, then there will be n petals. But if the value of n is even, there will be 2 times n petals. So for example, if you have r equals 3 sine of 5 theta, because my value of n is 5, which is an odd number, there will therefore be 5 petals. If I have r equals 7 cosine of, I'll say, 8 theta, then because my value of n on the inside here is 8, which is an even number, there will therefore be 2 times 8, or 16 petals in this rows. This is a very nice thing to understand and recognize, as if you go into the problem already knowing how many petals to expect, then once you've graphed a portion of the curve, then you should be able to generate the rest of it based on your knowledge of how many petals to expect. The last concept we have here is lemniscates. Lemniscates take their name from the Latin word lemniscatus, or decorated with ribbons. These curves often take the shape of a figure 8 or a ribbon shape. They take the form of either one of the following, where a and b are non-zero real numbers, and n is still a natural number. We have r squared equals a sine of n times theta, and r squared equals a times cosine of n times theta. You may notice that these equations look very similar to those of roses. Basically, what a lemniscate does is that a lemniscate will take the equation or the graph of a rose, and because you would solve for r by taking a square root and getting something like a sine of n theta underneath a square root, that means that any petals that would be created by an output that is negative here, which would now be under a square root, would no longer exist. So, for example, a rose of, let's say, 4 sine of 2 theta. This would normally be a rose with 4 petals because my value of n is 2, which is even. If this was r squared equals 4 sine of 2 theta, well, this rose of 4 petals, which would end up looking something like this, this rose of 4 petals is going to no longer include the petals that would have been created via negative radii. that means half the petals really are going to get canceled out. Meaning that you're not going to have this shape anymore. You're going to just have one of these petals, the next one would no longer exist, and then you'd have another petal after that. So you'd have a shape like this that looks somewhat like a figure 8 or kind of like a tied ribbon.